All right, here is part 2 of the acceleration notes. I had to break these up, so here's the second part, finishing up acceleration. All right, signs of the acceleration. Positive acceleration of plus 4 meters per second squared adds plus 4 meters per second of velocity. So it's adding velocity each second. So 0 to 4, 4 more is 8, 4 more is 12, 4 more is 16 as you go across. Negative acceleration of negative 4 meters per second squared adds negative 4 meters per second of velocity each second. So if I'm going 16 this direction, I'm going to basically be subtracting 4, subtract 4, subtract 4, subtract 4 until you get down to 0. All right, what is the sign of acceleration in each of these 4 possible cases? So number 1 is speeding up in the positive direction. What do you think it is? That one is positive acceleration. Slowing down in the positive direction. So now we are going uphill. We're slowing down in the positive direction. What's it going to be? That one is negative acceleration because it's slowing down in that direction. Speeding up in the negative direction. So if we're going faster in the negative direction, what's it going to be? Negative acceleration. And now slowing down in the negative direction. What is it going to be? Positive acceleration right here. Okay, a car is headed west, the negative direction, on a long straight road. The driver sees a red light up ahead and slows to a stop. Is the car's acceleration positive or negative? So the car is heading this direction. Which way is the acceleration going to be? Slowing down in the negative direction uses a positive acceleration because we're going to have to, if the car is going this way with its velocity, that's a negative velocity, you're going to have a positive acceleration going this way to slow it down. What does minus 1 meters per second squared mean? Can you describe 2 ways that an object could have a negative acceleration? The velocity changes by 1 meter per second every second. So every second you're going to go negative 1 meter per second. Here's some examples. It could slow down in the positive direction, or it could speed up in the negative direction. There's 2 different ways that could happen. All right, now we're going to talk about graphs with this. Acceleration on the velocity versus time. So we have velocity on our y-axis and time on our x-axis. A car moves at a constant speed of 3 meters per second for 3 seconds. What does this look like on a velocity time graph? So, since there was no acceleration, it's moving at the same speed, you have a flat line there at 3. No acceleration or constant velocity. The car is then going to accelerate to 6 meters per second over the next 3 seconds. What would this look like? So now, since now that there's acceleration from 3 to 6 seconds, we're going from 3 here to 6 here, and the straight line between those is your positive acceleration, or your changing velocity. Okay, the car continues at 6 meters per second for another 3 seconds. What would this look like? So now, again, we have no acceleration, and we have another flat line. It stays at the same velocity, which is 6 meters per second. The acceleration causes the velocity versus time graph to have a non-zero slope. Positive acceleration, you have a positive slope. So when you understand slope, remember when you talked about slope with your graphs in math? So going up into this quadrant gives a positive slope. That gives you positive acceleration. Slope basically is going to be the change in velocity divided by change in time, which is acceleration, change in velocity. So the slope of your line is actually your acceleration. The slope of the line is the acceleration. Calculate the acceleration from t3 to t6. So I'm going to do this. So the change in velocity is going to be Vf minus Vi, and Tf minus Ti. So if my final velocity was 6 and my initial velocity was 3. My final time was 6. My initial was 3. What does that give me? 6 minus 3 gives me 3. 6 minus 3 is 3, so 3 divided by 3 is 1 meter per second squared. This looks like it's the same slide again, except it's drawn in your little vertices down here to show you. All right, position versus time. An object starting from rest accelerates at 1 meter per second squared. Its velocity increases with time, making a linear graph versus time. Linear means you have this straight line. That means linear. What does the position versus time graph look like? So now instead of velocity time that we had here, we have position time, sometimes called distance time. What would it look like? Well, if my velocity is increasing every second, what happens to my position? So as velocity increases, the slope must change because it's getting faster and faster. So the distance time graph is going to have this curve to it as it travels up. So a big curve, because as time goes by, you're going to cover more and more ground because you're going faster and faster and faster. All right, curves versus lines. Acceleration creates a sloped line on a v versus time graph. Acceleration causes a curve on an x versus time graph. So vt, you get a sloped line. dt, distance time, you get a curve. So sloped, curved. Negative velocity, negative curve. Again, just pointing out velocity time and position time, you get positive acceleration curves up into this quadrant, negative acceleration goes down. A lot of stuff on this page. Understanding acceleration. An acceleration of 5+ miles per hour per second means that the speed changes by +5 miles per hour every second. B, acceleration is the rate at which velocity changes. C, acceleration is the change in speed divided by the change in time. D, acceleration is the slope of the speed versus time graph. How does statement A relate to the diagram below it? What does +5 miles per hour per second mean? So it says that if you look at these, an acceleration of +5 miles per hour means that the speed changes by 5 miles per hour every second. So it's going from 30 to 40 or 30 to 35 and back and forth. The rate of change, you see each arrow is changing by the same amount each time, or going down by the same amount each time. This is basically just the formula for acceleration, and this is explaining the slope of, we have positive acceleration here, we have negative acceleration here. Again, it's just talking more about this. How does the equation represent statement C? Translate the symbols and operations into English, giving numerical examples of a change in velocity divided by a change in time. We've done several of those already. We have acceleration is the change in velocity divided by the change in time. What does it mean that the lines on the velocity versus time graph in diagram D go up then down? How does this reflect in the concept of acceleration? Again, like I said, positive acceleration, negative acceleration. Positive, negative. Define and describe accelerated motion. Here's our assessments. Acceleration is the rate of change of velocity. For motion along a line, an object that is accelerating is speeding up or slowing down. A car changes its velocity from 0 to 20 meters per second in 4 seconds. What is its acceleration? So a change of plus 20 meters per second over 4 seconds is an acceleration of 5 meters per second squared. Because our formula here, you have the change of, you're going from 0 to 20, so your change is 20 divided by 4. 20 divided by 4 is 5. A car initially travels at 25 meters per second, comes to a stop in 3 seconds. What is its acceleration? So this one's going the other direction. We're going from, the change is always VF minus VI. So the final was 0, and it was going 25. That's how we get the negative 25 here. And it happened in 3 seconds, so you get negative 8.3, showing that it's slowing down, because it went from a velocity or speed to 0. An object starts from rest and accelerates at 2 meters per second squared for 10 seconds. What is the final velocity? Final velocity is going to be 20 meters per second. If you look at this, if it goes 2 meters per second for 10 seconds, so we went all the way up to 10 seconds, so 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. The motion of a particle along a straight line is depicted in the graph. What is the acceleration of the particle from 7 seconds to 10 seconds? So we're just looking from here to here, from this point to this point. So from here, it's 40 meters per second squared, because our change is, the final is going to be 0 at this point. Here it's 120. So 0 minus 120 divided by, and the time it takes is 7 and 10, so 10 minus 7 is 3 seconds, giving you the negative 140 meters per second squared. That's it for the notes. Good luck.